Hi student, welcome back to virtual reality class. So for this week topic is on virtual reality modeling. So I hope that at the end of the chapter you'll be able to understand what is the modeling for virtual reality, what are the options used to generate or to create your own 3D object to be used inside VR modeling, what is the illumination, what is the texture mapping, and also the application of this virtual reality modeling. So here is the VR system architecture, where basically we will receive the task from the user, and then the user will need to interact with the VR engine through the input devices, and this VR engine will request the task or the related VR action inside the software or database, and this software and database will send that requested task to the VR engine, and then we send back to the user through the output devices. So as last topic, we covered about the VR engine component here. So this week what we're gonna cover is that inside this component, which is on the modeling and VR toolkit. The VR object will manage the object model too. So basically the VR object modeling cycle consists of I/O mapping, input and output mapping, geometric modeling, kinematic modeling, physical modeling, intelligent behavior, model management. So all of these are considered as a VR object modeling cycle. In order to model the object to be used in the VR environment, we should model the object surface shape. Alright, so this is the first thing that we should pay attention to. First is we need to model the object surface shape, and also we also need to consider the object appearance, and also in terms of lighting, which is considered about texture mapping. So let's look into the first component first, is on the object surface shape, okay, or in terms of polygonal object. Here are the few options that we have when we want to create or develop our own object polygonal shape or geometric 3D model to be used inside our VR environment. So here are the options that we have or available that can be used. First is can be programmed from scratch using OpenGL or other toolkit editor. Okay, so this is the first option. We can program it from scratch, okay, from you yourself to do it, either from the any other open source such as OpenGL or other toolkit editor. So when you choosing this method, is quite tedious and requires skill. Okay, it's quite tedious. This means quite boring to do this because you have to develop this or design this from scratch. And of course, it requires a skill as well to come up with a very nice design model of the polygonal shape or geometric 3D models. And option number 2, we can obtain it from CAD file. Okay, here are the option number 2. We can get the 3D model or any polygonal shape from the CAD file. CAD is a computer aided design file. Okay, we can get from here as well. And the third option that we have is we can create your own using 3D digitizer or stylus, or through a 3D scanner. Okay, here are the option number 3. If you don't want to program it from scratch, you can obtain from CAD file, or you can create your own by using the 3D digitizer or stylus or scanner. Okay, a 3D scanner. And option number 4, you can purchase from existing online database. Okay, of all the options, this one is not not free. You can purchase from the online database if you want to get certain geometric 3D models. So here are the few options that we have in order to create your own object geometric 3D models. Here is the example of the option where you're going to use the 3D scanner, okay, to create your geometric modeling or to create your 3D object to be used in VR environment. So this is the 3D scanner. It's gonna scan this object, okay, and then you will get this directly, okay, this 3D model to you in the soft copy. So it's easier for you, okay. You can just use this scanner, scan the object, and then you will get the output. And this scanner can be scanned up to 3 meters long. Okay, so you don't have to have a direct contact with the object. So 3 meters is long enough to take the object. So if you are choosing the option of having the geometric modeling or 3D models by purchases from online databases, so there are a few consideration that we need to pay attention to, which is if you choose the low resolution model. For this example, I have two figures here. This figure is only have 600 polygon compared to this one with the higher resolution model which have 20,000 polygons. So the one with low resolution model or less polygons, your 3D, okay, your polygonal shape will less realistic compared to the one with higher resolution models because it have more polygons, so it have more detail, so it look more realistic. So you have to pay attention whether you want to go for the high realistics or you want to go for the low resolution model to save the memory. So it's based on the purpose of that project as well. Here is the table of comparisons from the option that we have in order to model your 3D object geometry to be used in your VR environment. First option is using toolkit or editors. So the features for this toolkit or editors is quite tedious and requires some skill to develop the 3D. The source is like OpenGL, Starbase, and so on. And then if the option is using CAD program, okay, computer aided design program, the features of this is quite interactive and is existing the technology. Okay, it's the existing technology that we have nowadays. The source is AutoCAD or Autodesk 3D Studio and etc. Or we also can use the 3D digitizer, which is quite interactive and allow for the custom models. Okay, you can custom your own models because we have a choice to do this. The source is like Autodesk Incorporation, Mirror Imaging, Polyhemus Incorporation, and etc. Or beside 3D digitizer, you also can use the 3D scanner. Okay, it can be considered as a fast or multiple acquisitions and when it's involved large project. Okay, the source is like Polyhemus Incorporation, Syra Technologies, and etc. And then the last option is that if you need to purchase from the online database, okay, from the commercial 3D databases. So the features from this is that is vertex list, is quite connectivity, and you can have a static model, and then is also pay attention on the level of detail of the models. The source is like viewpoint incorporation and etc. Besides considering the object surface shapes, what we need to pay attention to is in terms of object appearance as well. Okay, now we already covered about the object surface shape in the previous. Then next we're going to cover about on the object appearance as well. When we talk about object visual appearance, here are the components that we should pay attention to that contribute to this object visual appearance. First is in terms of the scene illumination, whether it fall under local illumination or global illumination, and also on the texture mapping, multi-textures, and also the use of textures to do illumination. Let's look into the differences between the local illumination and also global illumination. So what is local illumination? Local illumination is the idea that objects are only illuminated directly by the light source. For example, the shading model that use this local illumination is like flat shaded, ground shaded, and also Phong shaded. So the local is just the object is only illuminated by directly the light source. While in global illumination, the idea is that the object do not only reflect light to the viewer, but also to other objects as well. Okay, this is in global illumination. Is that object is not only reflect light to the viewer, but also to the other object as well. If you can look into these two figures here, on my left hand side here is the local illumination. Okay, so here is that the object of this ball are only illuminated directly by the light source. Here is the light source, so this ball is just directly being illuminated by the light source. by, on your right hand side here, the figure on your next right hand side here is referred to the global illumination, because this object, okay, this ball, is not only reflect the light to the viewer but also to other object as well. Okay, here you can see from this ball is reflects the wall, the red wall here as well. Okay, and then is also taking the reflected light from on the top of this wall as well, and also from this green wall, and also from this box as well. Okay, so this is the concept of scene illumination for the local illumination versus global illumination. Between these two objects, which one that you think is reflects more realistic looking scenes? I believe that you guys will choose this one right on my right hand side. So this one is the effect of using the Radiosity illumination. So basically Radiosity illumination is from the global scene illumination category, which when we apply this Radiosity, it will result in a more realistic looking scene. So with Radiosity is basically is more toward the reflection from the light source. So if you look at the left hand side figure here, this one is without using the Radiosity, with no light source, so everything will look like the same color, the same shading in all the environment inside here. But when you apply Radiosity on the right hand side here with the light source, from here on top of this you will see there is a lighting coming to the environment as well from here, and also from the chair down here also you will see the shadow. So it will result in a more realistic looking scene by applying the Radiosity. The purpose of having the texture mappings in the VR environment is to increase the scene realism. Okay, so our scene will not look boring or boredom without any texture at all. So the purpose of having this texture mapping is to increase the realism of your scene. So basically, what is texture mapping? Texture mapping is nothing is the application of pattern or image to 3D dimensional graphic to enhance the realism of their surface. Okay, so it's just like you add a wallpaper to your object. Here I have the example. Here is the object of this sphere here, and then this is the texture. And what this texture mapping is doing is that it's gonna use this texture to wrap this object. So we have this texture mapper object like this. Okay, it's just like you have the object and then you have a wallpaper, and then you use that wallpaper to wrap this object. So you have the more interesting or more realistic scenes, okay, to your object. So this is the texture mapping, is how you map the texture to your object. Can you imagine this room without any texture at all? So your scene will look a bit more boredoms or boring without any texture. So they have applied a texture mapping into this scene on several object or surface. If you can look in this wall, here is the texture, and also the texture also have been applied on this painting. Okay, this one and this frame as well also have the texture. And then if you look carefully on the sofa here, the furniture here also have been applied with the texture as well. Also the vase and also the carpet as well. Here you will see there is a texture applied on this scene. So you will see that this room is full with the texture to increase the realism of your VR environments. So how to create textures? Textures basically are available online in texture libraries of, for example, a car, a people, a construction material, and etc. So you can find the available online texture in the libraries, or you also can get the texture from your own scan photograph. Okay, you can scan the photograph and you can have that as a custom textures, or you can use your interactive paint program to create a bitmap of that textures. So what is multi-texturing? Based on the name itself, one is multi, one is texturing. So multi means more than one. So basically multi-texturing is the use of more than one texture at a time on a single polygon. And this multi-texturing process is allows several textures to be applied one by one in the pipeline of texture operation to the same polygon. So if you can look at this example down here, I have two textures here. One is these textures, and then I have one more of these textures. Okay, so I will use these two textures to combine together so that I will have a result like this for this object. Okay, so it will add more realistic to this object as well, because it's the combination between this and this. So we have the effect or result of this multi-texturing of the object like this. So here are the type of textures that we have that allow for more complex textures. Okay, this one is a normal texture. Okay, this one is the example of normal texture. We also have the background texture, like this is a background texture. And then we have transparency texture. Okay, it's transparent. We have reflectivity texture here. Okay, the texture that have some reflection. And also bump maps. Okay, bump map is allow for the a bumping surface. Okay, a bumping textures that's not a smooth surface. When it's come to the kinematic modeling, so basically is dealing about the motion. Okay, the motion of the modeling. So the kinematic modeling studies is about the motion of the virtual object. Like in this figure, you will see there is a virtual object representing a human, okay, an avatar. So kinematic modeling is dealing about how to move this virtual object. What is object hierarchies? Basically, object hierarchies is defined as a group of objects which move together as a whole, but whose part can also move independently as well. And a hierarchy implies at least two levels of the virtual object. Okay, either at a high level object as known as the parents, and also the low level object as known as the children. And basically, the motion of a parent is replicated by its children, but not on the other way around. Example of the object hierarchies is the virtual human and also the virtual hands, where each of these have its own hierarchies. And at the top of this hierarchy is known as the world global transformation that determine the view of the scene. So let's look into the next slide to find out these object hierarchies examples. Here is the example of the object hierarchies in virtual reality. As you can see that we have this avatar, okay, this football player, okay, one football player here. And then what we can do to this virtual reality object is that we can divide this into the model of hierarchy. Okay, if you look at this sub chart here is a hierarchy of this model, which the main part of this is the football player up here. And this football player can be divided into upper body and also lower body. And what consists inside this upper body is consists of the right upper arm, okay, and then left upper arm. And under this right upper arm is have the right lower arm, and then under this left upper arm we have left lower arm. Okay, it consists of several parts of here and here. Okay, upper part and lower part for both sides, right and left. And for the lower body, we have the right upper legs. Okay, we have the right upper legs here, and also we have the right lower legs. Okay, and then we also have the left upper legs. Okay, is here, and also we have the left lower legs is here, right? So basically, this is how we divide the VR modeling, okay, into the object hierarchy so that it's easier for us to manipulate or make a motion to it. Okay. What is avatar and agent? Okay, there are two here. One is avatar, one is agent. So basically, avatar is something that we use as a representative of us as a human in the virtual environment to interact with the virtual world in the form of embodied virtual identity that mark the presence of us in that VR environment. Okay, this is avatar. While agent is another form of virtual representation that share similar features with an avatar. So what is the difference between avatar and agents? The main differences is that avatar is controlled by us as a human. Okay, avatar is controlled by us, while the agent is basically controlled by the computer algorithm. Okay, so this is the main differences between avatar and agents. When we create or develop the 3D models to be used in the virtual environment, it is necessary for us to maintain the interactivity and also the constant frame rates when rendering the complex models. Here are the several techniques that we can use to help to maintain this interactivity. First is the level of detail segmentation, cell segmentation, offline computations, lighting and bump mapping at rendering stage, and last one is the portals. And why do we need all of this technique to maintain this interactivity and constant frame rate? Because all of this technique will help to design and to help the VR engine to render complex virtual engine at interactive rate without impact the simulation quality. Okay, so by applying those technique here, it will help the virtual engine or virtual reality engine to maintain the same simulation quality without affecting the quality when renderings. So that's all for today's topic. So let's recap what we have learned in this chapter. So we have learned a few options in creating a geometric 3D models. We have learned about the scene illumination, which consists of two, which is the local illumination and global illumination. We have learned about what is texture mapping, the kinematic modeling, the object hierarchies, avatar versus agent, and also model management.